Okay, ladies and gentlemen, let's see this question on the surface area for 19.6. It says we should calculate the surface area generated when the curve given by, this is the equation of the curve, y equal to 1/4 x squared minus a half ln x on 1 less than or equal to x less than or equal to 2, that gives you now the limit of integration, is rotated about the y-axis. So like we all know, each time you get the problem of surface area, it's good to know the rotation because it tells you how your formula for surface area starts, and then you know the limit, it tells you how your formula ends. So from my interpretation of that equation, I will go to my N6 formula sheet looking for a formula that starts with AY because it's y-axis rotation, but ends with dx because my limits are in terms of x. So on my formula sheet, I'm looking for AY, not on page 6. I go to page number 7. It's the first formula on page number 7, which has AY equal to the integral from a to b. I get 2 pi x, then the square root of 1 plus dy over dx, or d squared, then dx. So that is the formula that matches my problem. So that's how we expect an N6 student to interpret these questions. If you have y-axis rotation, your formula must start with AY, then the limit in terms of x tells you how it ends, then that formula will start taking you through the whole process. So we can then bring down our function, which is y equal to 1/4 x squared minus a half ln x. So use that function to get dy dx. So luckily y is already the subject, so we don't need implicit differentiation here. If I differentiate the first term, you remember we are only differentiating the variable, never the constant. If I differentiate x squared, it gives me 2x, then I multiply by 1/4, that gives me 2x over 4, then minus a half, we don't differentiate constant. If we differentiate ln x, we'll get 1/x. So if you simplify this, this will be telling you that your dy over dx is equal to x over 2 minus 1 on 2x. That's what our dy dx gives us. Then we can move on now and do the part of squaring. You see the next thing in the formula is to square your derivative. So we are squaring dy over dx. That means I'm squaring x over 2 minus 1/x. 1/2x, so that's what I have to square. And again, it takes us to this familiar expansion, which I keep encouraging all my N6 students to be used to. When you are expanding a binomial to the power 2, this is something that you can't do the N6 question paper to the end without coming across. So the fastest way of getting it is to take your a, you square it, you get your a squared. You take your negative b and square it, it will give you positive b. Then the middle term, you just take the power 2 times a times minus b, that gives you minus 2ab. So that's how fast you can get it. But I keep insisting that for you to master this technique, please make sure the power is a 2 and you've got a binomial. Don't go to the power 3, you start doing these kind of things, or the power 4, that will be something else. You will need to take your time and look for the way to do that. So now we can do our expansion now. So this is my a, which I will square it, that will give me x squared over 2. Then my b is negative 1/2x. If I square negative 1, it gives me a positive 1. I square 2, I get a 4. Sorry, here was the square of 2 is also a 4. I square x, I get an x squared. Then for the middle term, you look at the way it is written. The 2 there is the power, a is the x over 2, b is the 1/2x. So if I want to take my time and do that, it means I'm taking my power, which is a 2, I multiply by a, which is x over 2, I multiply by b, my b is negative 1/2x. If you multiply this, you see that this 2 will take care of this x will take care of that. You're only left with negative 1/2. So it means our expansion there gives us negative 1/2, then plus. So that is what I expect to see from our simplification. So if we get that, then this is telling us that we've managed to do the squaring. So the next thing is adding 1 to it. So if I add 1 to my square, I get dy over dx, all that square plus 1, this will be 1 plus x squared over 4 minus 1 over 2 plus 1 over 4x squared, which will take me to where the first and the third term are like terms. If I pull them together, I will be getting x squared over 4 plus 1 minus a half is positive a half, then plus 1 over 4 x squared. So again, we need to think out of the box here to see what this gives, because I can't take these 3 items under the square root. The square root will not manage them. So usually what I say to my students is that if you look at what you wrote here and what you wrote here, they are very close to one another. They are just like twins because everything looks the same. The only part that looks different are the signs. And the nice thing is that the item here, you know where it comes from. Therefore, this one must come from there with a sign that is opposite to that. So to simplify this, I just copy that, paste down, I change the negative sign into a positive sign. So that's how simple I see it. So I'll get x over 2 plus, I'm now changing the negative sign into a positive sign, plus 2 on x, all that squared. So if you want to confirm that, you see that if you square this, you get x squared over 4, you square this, you get 1 over 4x squared, then the item in the middle, it's just taking 2 times 2, or x over 2 times 1 over 2x, so you see x will cancel x, this 2 will cancel that, and left with 1 over 2. So guys, that's how simple it is. So for now, we can say the item under the square root is now sorted, and it is written in a friendly way to the square root because the square root can take care of the square. So if I get back to my formula, which is the integral from a to b of 2 pi x, then the square root of 1 plus dy over dx, all that square dx, then I know that in this formula 2 pi is a constant. You can step out, a and b are the limits that were given to us from 1 to 2. I put them there, then now you can see your x. Your x has every right to be here because the formula ends with dx, so I don't need to be looking for the meaning of x. If this was a y, then I would replace it by the original function. But since it is an x, it has every right to be there. So I will now take the square root. The item under the square root is what I did down there, which is x on 2 plus 1 on 2x, or that square dx. So the square root can now handle that square. So I'll be having 2 pi, the integral from 1 to 2 of x into x over 2 plus 1 on 2x after my square root has taken care of the square. So now for me to integrate, I must open the bracket and allow the x to go through. So if that x goes through, I'm seeing the integral from 1 to 2. You remember x is like x over 1. So while x is busy multiplying the numerator, 1 is multiplying the denominators. So if x multiplies there, I'll get x squared over 2 as my first term. Then if x comes here, I'll get x over x. Since 1 is going there, I'll get x over 2x. That will reduce to 1 over 2. So that's how my simplification goes across. Then I can now do my integral. So if I do my integral of the first term, if you integrate x squared, it becomes x cubed. Then because you have to add 1 to the power, then you divide by 3. 3 will meet the 2 there to form a 6. Then if I integrate a half x, that will just give me a half, sorry, if I integrate a half, that gives me a half x, which is the same thing as x over 2. So from here, I'm done with integration. It's now time to put my limit. So my ay is equal to, I get 2 pi. If I start with the upper limit, which is a 2, I get 2 cubed, that is an 8 over 6, plus 2 over 2, If I put 2 there, then I close my bracket, I start the process again, then I replace x by 1. If I put 1 there, I get 1 over 6, plus put 1 there, I get 1 over 2. Then I allow the calculator now to do the rest, knowing very well that 2 pi is common, so I'll just take 8 over 4, that's 8 over 6 plus 1, minus 1 over 6 minus a half, then I'll multiply by 2 pi. So I get 8 over 6 plus 1, 2 over 2 is 1, then minus 1 over 6 because of that negative, 1 over 6, then minus again, 1 over 2, if I get that, my answer gives me 5 over 3, then I multiply by 2 pi, which is a common factor, so I multiply by 2 pi, then my answer is 10 over 3 pi, so I've got 10 on 3 pi units square. If you are that person who is interested in decimals, it's also fine. That will give us 10,472 unit square. So guys, that's how we get that surface area. Thank you very much.